Good day, students. My name is Mr. Iwale Matthew. I'm here to take you mathematics, and our topic for today is logical reasoning. Under it, we shall be looking at simple statements, meaning of simple statement, true or false statement, negation of simple statement, conjunction statement, implication statement, and by implication statement. Now let's start with logic. What do we even call logic? Logic is a rule that specifies the meaning of mathematical statements. So these rules help us to understand and reason more. So it's logic. So whenever you have given rules which makes you to reason, then it is regarded or referred to as logic. Now let's go to propositional logic. A proposition is the basic building block of logic. It is defined as a declarative sentence that is either true or false. So a propositional logic is just a declarative sentence that is either true or false, but not both. So it can only be false or true, but cannot be both. And the truth value of a proposition is true, which is denoted as T, if it is a true statement. So if it is a true statement, so it is denoted as T. And it is false, which is denoted as F, if it is a false statement. So if the statement is false, you represent it as F. And if the statement is true, you represent it as T. For example, the sun rises in the east and sets in the west. So you can see, truly the sun rises in the east and sets in the west. So the sentence in example 1 is true, which is denoted as T because the statement is true. The second example, 1 plus 1 is equals to 2. Yes, that is true because when you add 1 and 1 together, you have 2. So this is true statement, which is denoted as T. But looking at the example 3, B is a vowel, which is wrong. B is not a vowel. So this statement is denoted as F. Why? Because it is invalid, because it is not true. Now let's look at the truth table. The truth table is the compilation of all possible scenarios in a tabular format. So the truth table is just a chart which is showing a tabular format of logical connectives. And we shall look at on the next page, we shall look at the logical connectives. Now let's look at the most common logical connectives. The first one is negation. Negation, which means not, which is the opposite of a statement. If P is a proposition, then the negation of P is denoted by, you can see the symbol. So the symbol there represents negation of P, which is translated to simple English, which means not P, or it is not the case that P. The truth value of negation of P is the opposite of the truth value of P. So when we are talking about negation, is the opposite of the truth, of the true statement. Now let's look at the truth table in the next page. So you can see the table. We have P to be true. So if P is true, the negation of P will be false. And if P is false, the negation of P will be true. For example, the negation of it is raining today is it is not the case that it's raining today, or simply it is not raining today. So if I say that it is raining today, the negation is what? Is not raining today. She is walking. The negation of that statement is she is not walking. So the next connective is conjunction. Conjunction. For any two propositions P and Q, their conjunction is denoted by, you can see the symbol as well. So that symbol represents and in a conjunction, which means P and Q. So the conjunction P and Q is true when both P and when P and Q are true. So under conjunction, the rule is when P is true, when statement P is true and statement Q is true, then they will be true. Otherwise, if any of the two is not true, then it is regarded as false. So don't forget, if you want to put it on the table now, okay, let's look at the table in the next page. For instance, when P is true and Q is true, so you can see that P and Q are what? Are true. Why? Because P is true, Q is also true. Now look at the second one. P is true and Q is false. You can see that it does not satisfy the rule that P and Q must be true. So if P and Q are not true, then the statement will be false. Then the next one is when P is false, Q is true, then P and Q will be false. Likewise, if P is false, Q is false. So P and Q will also be false since they are not satisfying the rule. For instance, example, the conjunction of the preposition P, today is Friday, and it is raining today. P and Q is today is Friday and it is raining today, which means both P and Q must be true. So for P and Q to be true, today must be Friday and it must be raining today. The preposition is true only on raining Fridays and is false any other raining day or on Fridays when it does not rain. So it means if it rains and it's not on Friday, then it is false. Now the next one is disjunction. Disjunction. For any two propositions P and Q, their disjunction is denoted by, so you can see that is the opposite of conjunction, the symbol, which means P or Q. So it means conjunction is and, but disjunction is or. Disjunction P or Q is true when either P or Q is true. It means either P or Q must be true. Either P or Q must be true. Otherwise, it will be false. Now let's look at the truth table of P or Q. Now, P is true, Q is also true. Then P or Q will also be true. Why? Because either of them, one of them must be true. And the two of them is now true. So definitely P or Q will also be true. Now when P is true, Q is false. P or Q will also be true. Why? Because one of them is also true. And if you have P is false, Q is true. P or Q will also be true. Why? Because one of them is also true. But if P is false and Q is also false, definitely P or Q will be false. Why? Because none of P or Q is what? Is true. Example, the disjunction of the preposition P, today is Friday and it is raining today. P or Q is today is Friday or it is raining today. Don't forget, you can say that the two of them is true. This preposition is true on any day that is a Friday or a raining day. So this statement is true if P is Friday and it is raining, or if P is not Friday and it's raining. So either one of them must be true. So if one of them is true, then it is P or Q is true. But if neither of them is true, then they will be what? They will be false. So it is false on any other day than Friday and it does not rain. So when it does not rain and it is not Friday, then definitely it is false. Now the next connective, implication. Implication. For any two propositions P and Q, the statement if P then Q. So it means under implication it is if P then Q is called an implication, and it is denoted by its own symbol as well. You can see its symbol clearly. In the implication P, if P then Q is called the hypothesis or antecedent or premise, and Q is called the conclusion or consequence. Now, when you look at this law, P is the hypothesis. Why? Because it is when we are talking of hypothesis, it is a guess, when you guess right, or when you assume to be true. And when we are talking about conclusion here or consequence, it is just like a value. So for this rule under implication, we shall look at the table now. The implication if P then Q is also called conditional statement. So it means the implication statement can also be called conditional statement. The implication is false when P is true. That is when P is true. And Q is false. So you can see its own rule. It is only false when P is true and Q is false. So it means Q will be the one to determine if it will be true or false. So if Q is not false, then if P, then Q will be what? Will be true. Okay, let's look at the table. We have P to be true, Q to be true. Definitely it will be what? If P, then Q will be true. Why? Because Q is not false. Now the next one, when P is true, Q is false. Then if P, then Q will be what? Will be false. Why? Because Q is having false now. Because Q is false. And if P is false, Q is true. If P, then Q will be what? Will be true, because Q is not false. The last one, under the table, we have P is false, Q is also false, then it will be true. Why? Because Q is taking the false. So when the two statements are false, it will be true. When the two statements are true, it will be true. But when the Q is having false, you can see the implication is false when P is true and Q is false. So P must be true and Q must be false before it can be what? It can be false. But when P and Q is not true and false, then it is not false, it will be true. So for example now, if it is Friday, then it is raining today. It's a preposition which is of the form P, if P, then Q. The above proposition is true if it is not Friday. You can see, if it is not Friday, that is if P is true. Or premise is false, which is, or if it is Friday and it is raining. If it is Friday, that is true. If it is Friday. Now, and it's false. It is false when it is Friday, but it's not raining. But it is true when it is what? It is not Friday. Or if it is Friday and it is raining. So you can see, because it must satisfy the rule that if P is true, P must be true, and Q must be what? Must be false. But when P is true, Q is also true. You can see if I say that if it is raining, it is Friday and it is raining. That is what? Is a true statement. But it can only be false if P is true, statement P is true, which is if it is Friday, and if F is false, if it is not raining. So if it is on Friday and it's not raining, that will be false. Now, by conditional or double implication, for any two propositions P and Q, the statement P, if and only if Q is called a biconditional and is denoted by its own symbol. So it means under biconditional implication statement or double implication statement, you have if and only if. That is P, if and only Q. The statement P, if and only if Q, is called a bi-implication, which is the opposite of implication. P, if only P and Q, has the same truth value as if only P and Q. The implication is true when P and Q have the same truth values. So it means when P and Q has the same truth values, then the implication is what? Is true. And it is false if they do not have the same value. So the truth table of P and Q will be, now when P is true, Q is also true. P, if only if Q is what? Is true, because both P and Q are having the same value. P is true, Q is false. So when the two of them are not having the same value, it will be what? It will be false. Next one, if P is false, Q is true. It will also be false. Why? Because they are not having the same value. And if P is false, Q is also false. If and only if P and Q will also be true. Why? Because they have the same value. So under biconditional statement, both P and Q must have the same values. For example, it is raining today if and only if it is Friday today, or it is raining today if and only if today is Friday. You can see when both are true, or when both have the same value, it is true. So you can see the table. Now, is a proposition which is of the form P, if and only if Q. The above proposition is true if it is not Friday and it is not raining. You can see negative, negative. P is negative, Q is also negative, which is Q is false, P is also false. Or if it is Friday and it is raining, which is true and true. It is Friday, true. It is raining, true. And it is false when it is not Friday or it is not raining. So it is false when it is Friday and it's raining, or when it is Friday, when it is not Friday and it is raining. So under biconditional statement, the two, both P and Q, must have the same value. If it is raining today and today is Friday, then that will be what? That will be true. If it is not raining and today is not Friday, it will also be true. But if today is not Friday and it is raining, it is false. And also, if today is not Friday and it is raining, or if it is raining and today is not Friday, then it is false. Why? Because the two statements are not of the same kind. So by the end of the class, I believe you should have been able to know what we call negation, conjunction, disjunction, implication, and biconditional statement. Don't forget, negation is the opposite. Conjunction is represented or denoted by and disjunction is denoted by or. Implication is if P then Q, and bicondition is if and only if. So this is the end of the class for today. You're having a class activity which should be submitted latest by Friday. And you have me online anytime between that day. If you have any question, you are free to message me on my WhatsApp privately. So by Friday, we shall be meeting again. So I will give you an assessment by Friday. So if you have any question, you are free to ask. So number one, give an example of logical statement, which is what we have explained in the second page. Give two examples of true nor false statement. Write the negation of the statement. All polygons are quadrilaterals. You can see, very simple. So goodbye.